Okay, so in the previous video we talked about how there can be three cases with the inscribed angle. So now we're going to use a proof, and we learned about proofs last semester where we have two columns, we have statements and reasons, and we use this to come to a logical conclusion or to prove something true. And so we're going to learn about the inscribed angle conjecture at this time. So in the case one, we had the inscribed angle going through the center of the circle. And this is the given. So the given is that the measure of angle of the inscribed angle, MPT, what says angle MPT is inscribed in circle O, which is what I just mentioned. The measure of the angle is, let's say, is the measure X, and point O lies on the diameter, line segment PM. They want us to prove that the angle is equal to half of the measure of arc MT. So remember, we always start a proof with the given, and that's what we see here. And what I want you guys to do is because you guys are going to have to screenshot the circle above and use markup to annotate the circle above to show the proof. So you're going to take a picture or a screenshot of this. And I'm just going to talk through it and guess the markings that I make along the way that you think will be helpful to you as well. You can go ahead and annotate that. So the given says that this angle right here is X, so you can go ahead and annotate that. So like I said, we always start with the given. And let me write that a little better here. The next statement that they said is that they say we can connect point O and T to form the radius OT, and that's what the dashed line is. And we can do that by construction. We can just literally physically draw it, right? I could even highlight it with a blue line if we needed to. So the statement 3, step 3 tells us that the measure of angle MOT, okay, that's the small angle that you see in the picture. So I'm going to go ahead and highlight that for you. So in yellow, this is the measure of angle MOT, and TOP, I'm going to highlight that one too, TOP. Those two that you see highlighted, both yellow and blue, are linear angles. And remember, what is linear pairs? What are those again? We learned about that last semester. Remember, linear angles are angles that add up to 180. And linear angles are angles that are right next to each other. They share a common side. So the reason we can say this is because they are next to each other, they share a common side. So that's by definition of the linear angles. As we look at this picture, we can also see on step 4 that OP, line segment OP, is congruent to line segment OT. And we can say that that is true because they are both radii. Okay? Step 5, it says that angle OTP is congruent to OPT. And we can say this is true because we just stated that line segments OP and OT are radii. If they're both radii, that means that they have the same length. So we can annotate this by using little tick marks. Remember we did that in last semester? We drew little tick marks, and then we have a little triangle there, triangle OTP, and it's an isosceles triangle. And because it's an isosceles triangle, the two bottom angles, the two base angles, remember that from last semester, are equal. So now those two angles are going to be X and X. And we're using all of these. This is the process that we're taking to be able to come up with the proof. So this is all logical reasoning, not just random statements. And I hope you're following. Step 6, they said that angle OTP plus OPT plus TOP is equal to 180 degrees. And why is that the case? Because remember, these are all of the three angles inside of this triangle that you can see in the picture. And remember, angles inside of a triangle add up to 180 degrees. Step 7, if you can tell in the statement in step 6, there are two OPTs, right? Or actually, we noticed we had in step 5, we mentioned that angle OTP and OPT were basically equal. And so basically we can just say that there's two of the same thing. So we're just going to keep angle OPT and just put a 2 there because it's twice of the same thing basically. This is by substitution from step 5. Moving on to step 8, it says that the measure of angle MOT plus the measure of angle TOP is equal to 180 degrees. And this is by step 3. And we already discussed why, and we know that linear angles add up to 180 degrees. Last two steps, step 9, it says that measure of angle MOT is equal to twice the measure of angle OPT. And that is the case because we can see that by substitution, steps 7 and 8, they both contain angle TOP. So if we eliminated TOP from both 7 and 8, we would end up with MOT and OPT, twice OPT, and that means that those two would be equal to each other. And that's why we can say step 9 that they are equal to each other by substitution. And lastly, if we can then say that the measure of angle MPT is equal to 1/2 the measure of, and this is a typo, it says the angle MT, but it's actually arc MT. And we can say this because and I'm trying myself to think here. Might be a typo here. I'm trying to figure out why. I think it's just, oh, okay, so it's just like a restatement. So the measure of angle MOT on number step 9, MOT, it says is twice the length of the inscribed angle OPT. And so we can basically go backwards and say that the measure of angle of the inscribed angle MPT then would be half of the measure of the arc MT, or even the angle MOT. There we go. And then we've proven that this formula is correct. We've proven the inscribed angle conjecture.